Good day and Assalamualaikum to the respected doctors. My name is Mulhim Mokhtar Muhammad Afandi, and today I will present about my research proposal entitled Comparative Study of Submerged and Solid State Fermentation for Enhanced Cellulose Production by Aspergillus niger. This work is conducted under the guidance of Dr. Nazrin Abdul Aziz and Dr. Siti Paulina Muhammad Buhari. And this is my table of content. Now, let's begin with the background of study. Aspergillus niger is a filamentous fungus widely used in biotechnology due to its ability to secrete high level of industrial enzyme and is generally recognized as safe classification. Among the enzymes it produces, cellulase are particularly important. These enzymes hydrolyze cellulose into fermentable sugar and are applied in various sectors including the biofuel, textile, food, and pharmaceutical industry. Industrial production of cellulase commonly employs two fermentation strategies, which is submerged fermentation (SMF) and solid state fermentation (SSF). SMF allows for better monitoring and control of process parameters such as the pH and temperature, which is advantageous for industrial scalability. In contrast, SSF offers higher enzyme yields and lower operational costs, but suffers from limited parameter control, especially in terms of moisture, temperature, and pH. This study aims to systematically compare these two methods using CMCS activity as the key indicator of cellulase efficiency. Next is problem statement. Although both SMF and SSF are widely applied, the comparative efficiency of this system in cellulose production by Aspergillus niger remains insufficiently characterized, particularly when using identical substrates and control conditions. SSF is traditionally favored for fungal fermentation, but Aspergillus niger often displays reduced enzyme yield under SSF due to challenges in maintaining consistent temperature and pH. Furthermore, because fungal growth is enhanced under high moisture conditions, SMF is often seen as more suitable. Previous comparative studies typically use various substrates such as coir waste, which makes it difficult to draw firm conclusions regarding system performance. To address this gap, this research will apply rice straw as standardized lignocellulosic substrate and evaluate both SMF and SSF under identical laboratory scale condition, focusing on the effects of pH and temperature on enzyme yield. The objectives of this study are as follows: to evaluate the effect of pH and temperature on cellulose production by Aspergillus niger under SMF and SSF condition, to compare the enzyme production efficiency of SMF and SSF using pretreated rice straw as the substrate. This objective aims to determine the more efficient and scalable fermentation method for industrial cellulose production. Now is the research flowchart. This flowchart summarizes the plant methodology. The process begins with the preparation of inoculum from Aspergillus niger, followed by substrate pretreatment of rice straw. Next, both SMF and SSF systems are set up under varying pH and temperature conditions. After fermentation, enzyme extraction is conducted and CMCS activity is quantified. Fungal biomass is also measured, and results are subjected to statistical analysis, including ANOVA and Tukey's test to determine the significance. Now, let's look into the methodology part. First thing first, we must prepare the substrate. So, for the substrate preparation, rice straw was collected from Kampung Sekinchan, Selangor, then will be dried, ground, and pre-treated with 1% sodium hydroxide to remove lignin and enhance cellular accessibility. After neutralization and drying, substrate was sterilized via autoclaving before use. Next, for the microorganism and inoculum use, Aspergillus niger spores were cultured on PDA and harvested using 0.1% twin AT solution. The spore count was standardized to 2 times 10 power of 6 spores per milliliter using a hemocytometer. Third, for the fermentation setup, for the submerged fermentation setup, 100 milliliter liquid medium with 30 gram per liter rice straw was used and put in 250 milliliter flask. Put into 250 milliliter flask. Next, it will be inoculated and incubated at varying pH and temperature. For the solid state fermentation setup, 5 gram of moistened rice straw at 60 to 70% moisture was added per flask. And it will also be inoculated and incubated under the same temperature and pH condition as submerged fermentation. Next, the optimization parameters. To investigate the effect of pH, fermentation media will be adjusted to values between 4.0 and 7.0 pH, while temperature will range from 20 degrees Celsius to 40 degrees Celsius. For enzyme extraction, the SMF culture will be centrifuged and the supernatant collected. In the solid state fermentation system, 50 micromolar of citrate buffer will be added to the fermented biomass, and the extract will be filtered and centrifuged. Next, for the CMCS activity will be measured using the DNS method with carboxymethylcellulose as the substrate. For the biomass quantification in SMF will involve optical density and dry weight, whereas in SSF, the gravimetric method will be used. All experiments will be performed in triplicate for statistical accuracy. The statistical analysis was used is ANOVA to assess the effect of pH and temperature on the enzyme activity. Also used is the Tukey's HSD test, which identifies significant group differences when P less than 0.05. Now, let's look into the Gantt chart. This Gantt chart presents the proposed timeline for the project. As we can see, from December and January, we'll focus on the inoculum preparation and substrate pretreatment. The fermentation and parameter optimization are scheduled for February and March, and April will be dedicated to enzyme assays and biomass evaluation, followed by statistical analysis, report writing, and presentation preparation in May and June. Now, this is my references. The methodology and the background presented are supported by the literature from peer-reviewed journals. The sources justify the research design and support the scientific integrity of the research proposal. I think that's all from me. Thank you.